4.1e is on solving systems all three ways. So we're going to start off and we're going to solve this system with elimination. We have x minus y equals 2 and 2x plus y equals 1. So if you notice, it's already lined up for elimination, right? Our x's are in a line, our y's are in a line, our equal signs and our constants are all lined up. So now we always want to check if we have a pair of opposites. So looking, it looks like x and 2x are not opposites, but negative y and positive y are opposites. So we don't have to worry about multiplying anything. So we are just ready to combine these two equations. If we have x plus 2x, that gives us 3x. Negative y plus y, well, that's 0, right? So our y's are eliminated, and this is going to be equal to 2 plus 1 is 3. So now I want to finish solving for x. 3x equals 3, divide by 3 on both sides. We get x equals 1. And then to find y, remember, we're just going to pick either of these equations, and we are going to plug our x value in. So I'm going to pick the top equation, so we get 1 minus y equals 2. Well, let's subtract 1 on both sides. That tells us that negative y equals 1. We have to get that negative out of there. So y equals negative 1. Remember, you always want to write your answer as an ordered pair. So we get 1, negative 1 is our solution. Let's really check this very quickly. So remember, I can pick either equation to plug it into. How about we plug it into the bottom one this time? So 2 times 1 plus a negative 1 equals 1. Okay, and remember, all I did there, I took my x value and my y value, and I plugged it into that bottom equation. Well, 2 times 1 is 2, plus a negative 1 is really just subtracting 1. 2 minus 1 is 1. So we're looking at is 1 equal to 1? Yes, it is. So we know for a fact that our solution is correct, just because we plugged it in to check. All right. Our second problem, we're going to be using substitution to solve. Okay, looking at our equations, so notice our system is the same one as the previous problem. So we're still looking at x minus y equals 2 and 2x plus y equals 1. Well, in order to substitute, remember, we need to have a variable that's isolated. So let's look at that top equation and isolate y. Negative x minus y equals 2. Well, let's get the x out of there. So negative y equals negative x plus 2. And then we need to divide everything by a negative to get y all by itself. So we get y equals positive x, because the negative x divided by negative 1 is positive x. And positive 2 divided by negative 1 is negative 2. So our isolated variable, or our slope-intercept form, is y equals x minus 2. So now that we have that, okay, notice this is our equation we just found, y equals x minus 2 and 2x plus y equals 1. We are ready to solve by substitution. So we're going to take what y equals and we are going to plug it into this equation. Since we just have a 1 in front, we don't need to worry about distribution. So when we plug it in, we're going to have 2x plus x minus 2 equals 1. Now x is our only variable, so we just need to solve. 2x plus x is 3x minus 2 equals 1. Well, let's move that 2 to the other side. So 3x equals 3. Divide by 3 on both sides. Hey, x equals 1. And then to find y, we just have to plug it into one of our original equations. Let's plug it into the bottom one this time. Well, 2 times 1 plus y equals 1. So that tells us 2 plus y equals 1. Well, let's subtract 2 on both sides. So we find that y equals negative 1. So we've got x, we've got y. So our solution is 1, negative 1. Okay, that's our solution using substitution. Notice that we got that same solution when we used elimination. All right, so let's try this one more time. So we're going to graph this time. So let's go ahead and graph. Remember, to do that, we need our slope-intercept form. Well, we already found the slope-intercept form for one of our equations, that top equation, so we just need to find it for this bottom equation. I'm going to subtract x on both sides to get my y by itself. So we find that y equals negative 2x plus 1. Okay, so now we have, between our last problem and this problem, we have our slope-intercept form. So we are ready to graph. Remember, we're going to start with that y-intercept. So the y-intercept for our first equation is -2. So here's -2 on my graph. Then I'm going to go up 1, over 1, up 1, over 1. Okay, then for our other line, well, our y-intercept is 1, so we would make a point at 1. And then this time we're going to go down 2, over 1, down 2, over 1. And then we connect our points. So now that we have our lines, we just need to find our intersection points. It's right here. So it looks like it's over 1, down 1. So we have the point 1, -1. Okay, so let's answer a couple of questions about these problems. So what did you notice about all three of your solutions? Hopefully you noticed that we got 1, -1 for every single problem. So our solutions were the same, so that means that it doesn't matter if you use graphing, substitution, or elimination. They're just three different methods to accomplish the same goal, right? To find the solution of your system of equations. Which method of solving do you prefer? Well, this relates back to our choose the best method from yesterday. That original problem was set up for elimination, right? Our x's were lined up and our y's. Since everything was lined up, elimination was the easiest method to use. We had to do extra work to solve by substitution. We had to do extra work by rearranging our equations to graph. And so just because it was set up for elimination, that's what makes elimination the preferred method. And that's our reasoning. Since it was lined up, it was already ready for elimination, so that's just the easiest one to use in this particular case. Okay, remember to answer the questions in your quiz and then hit submit when you are finished.